Hi everyone, Larry Wynn, CEO at Summit Imaging and Ultrasound and Mammography Equipment Support Organization. And today we got a special video for you. We've had so many requests from our customers all over North America dealing with accidental damage that occurs to transducers. So what you guys were asking from us was, could you build a video that describes how these probes are getting damaged? Well, we've seen thousands of transducers from our repair services, and we have actually collected that data and here to show you kind of what occurs accidentally along the way during the life cycle of these transducers. And so the goal of today's video is to educate you and possibly share it with people beyond the HCM community, users of the equipment, to perhaps educate on what could happen that you would never even know that causes a significant number of failures that are absolutely preventable. And so that's what we're going to take you through today. We're going to demonstrate some probes getting dropped, getting hit against machines, and to help you lower that equipment downtime, maximize that uptime so you can better serve patients. And so we've actually created a life cycle. In this particular case is a T-probe. We're going to be talking about the life cycle of a T-probe because these take a lot of abuse. They're in a very harsh environment. They go down the esophagus for a scan of the heart. No ribs in the way. Absolute beautiful image for doctors to use. And then the sterilization piece where they're sitting in some sort of acidic chemical to actually sterilize the transducer. We'll step through that life cycle, and in addition to that we have kind of a standard probe here that not all phases are applicable. However, the goal of protecting the equipment and preventing accidents along the way to prevent damage is very similar in nature. And so let's roll into our model. And so right now, we're going to begin with storage. Where is your T-probe stored? We're going to move on to transport vulnerabilities. We'll then go into an operating room or clinical use of a transducer when it's being used. Talk about those risks, what we're seeing happening with these probes that are damaged coming back to us. Transport to central processing, the centralized area where all the equipment of clinical use kind of goes as they travel in and out of rooms in a hospital. Decontamination, which is just kind of getting all of the debris off of these transducers. We actually add in inspection and testing. You want to do that right after decontamination to look for some certain things. We'll dive into what you should be looking for. Disinfection, which is the sterilization, really sterilizing this probe to get it ready for the next patient. And transport back to storage, which are similar vulnerabilities as transporting it to the OR or for clinical use. And then back to storage. And so this is the life of a transducer. It just keeps going over and over and over. And for healthcare facilities and hospitals out there, the goal is to get as many cycles as we can to serve as many patients and help them as much as we can. Now, in the event that a probe is damaged, this cycle can stop. And what we can do is assess what that failure could be, what that damage has occurred, and then getting a new piece of equipment, or perhaps using a repair alternative with a quick turnaround to reintroduce this asset to continue on this life cycle and lowering your costs at the same time. All right, I'm back. I got my scrubs on. Wanted to demonstrate being, a healthcare staff member who would be handling transducers throughout this life cycle process. And we're going to start with the first phase, which is after storage. There's some nice storage options for you. We'll get to that at the end, but we're going to start here at transport. And at transport, there's a couple of vulnerabilities here that we often see where damage occurs on probes. And let's just start with the obvious T-probe because these are actually damaged quite often when they're being transported. Now, when we're actually in hospitals helping kind of assess these kinds of problems or deploying our evaluations to show the hospital what could we do differently to help prevent damage, this probe is so long that it actually has a lot of force if it's swung around. And the part you want to protect the most is the tip. There are so many microelectronics in here with a very sensitive crystal that even the slightest bang on a surface will actually crack it enough to where the probe needs to be repaired or may need to be completely replaced. And so what we've seen is everything from hospital employees trying to carry it like this, which we don't recommend because you don't want this touching you, especially after it just came out of surgery, or if it just got used on a patient. You really don't want this entire insertion tube touching you at that point without the proper protective gear. We've seen people roll them up with the tip right here, and as they're walking around, the tip starts banging, as you can hear right now, on this metal casing here. We've even seen customers walking like this, and then the tip bangs on the can of the transducer. So what do we recommend? We recommend getting a proper transport box for this. We've seen some nice totes, but if you really have to, we really recommend coiling up, grabbing the handle, coiling up the cable, and now holding this right underneath the tip with some gloves. And this is a way to control all the heavy parts of this transducer, because the heavy parts are what's going to hit things, especially protecting this tip. So now you have full control of the tip of the transducer, you have control of the handle, and then this connector with a short leash here with your left hand or right hand will not swing around and bang things, especially keeping it away from the most sensitive part of the transducer, which is the T-probe tip with the crystal on it. So we recommend carrying it in a way where you can control it with the idea that things aren't going to be swinging around unnecessarily, because if you carry it like this, you can risk banging it into a table. Another one is actually banging it into side of doors as you're going in and out of rooms. So as we're transporting a T-probe, it's important to protect the tip, because oftentimes accidental damage occurs when just transporting this probe around. And for example here, door jams are a T-probe's worst nightmare. Now, that impact on the tip was completely on the tip against a metal door frame, and that will cause enough impact to damage all the microelectronics inside the head of the T-probe. So now we got a standard probe, just a cardiac sector transducer, and we recommend the same thing, coiling it up, holding the can in one hand, holding the transducer in the other. The difference is the crystal is right on top instead of kind of facing forward like the T-probe, but the same issues apply, is that you want to protect this crystal, especially from hitting the can. And the issue, sometimes when we see totes being used with T-probes and standard probes, is that they go into a box and then the crystal is next to the connector. And as people walk down the hall, the crystal starts banging onto the connector and therefore damaging that crystal, because this connector is full metal and this just has a rubber lens covering a ceramic crystal that's very fragile. So be careful as you're transporting them. Keep these two components away from each other because they're both heavy. They will slide into each other. And then in addition, this is what's going to get damaged, and this is what's going to cause your equipment downtime, because now the probe's no longer functioning. All right, now let's talk about the next phase, which is in the operating room. And what we've found, we've actually joined a lot of procedures just to observe how the equipment's being used, but more importantly, what's being used around it environmentally that could be inducing failures on T-probes and other standard probes as well. But let's just talk about T-probes. And we have some surgical tools here. We have a scalpel, scissors, other types of things that are all extraordinarily sharp. And one thing is, when the technicians are prepping for a procedure, we've seen these sharp tools right next to the transducer on the table. Well, the construction of this T-probe is a bending rubber that allows this transducer to articulate. And these sharp tools are very sharp to a degree where it will cause micropunctures into this bending rubber or even on the lens and compromise a transducer's not only performance, but also exposing the internals of that where stomach acid might get in there, some disinfecting fluids might get inside the transducers, and ultimately will eventually, if not immediately, fail a leakage test and therefore needing a repair. So the idea is to protect this section of the probe, being the most sensitive and the most vulnerable from sharp surgical tools, not only during preparation, but also when procedures are over, everybody's celebrating the success. T-probe gets put back on the table with the mess of tools there, and now these tools can accidentally slide and start hitting this probe in some areas that can cause some unnecessary damage. So we recommend separating the two. And so having the T-probe completely stored away from the surgical tools in the room will prevent a lot of damage. We see a lot of micropunctures in these bending rubbers. It's probably the most common failure for T-probes, and this is a common issue. Also, a lack of use of bite guards can cause some severe damage here as well. But one that we found us very surprised was these probes can lock. So I can lock this probe into a 90-degree position. This allows a probe to be articulated inside the patient to get a great picture of the heart. But even with the use of a bite guard, which would, traditionally, if this is inside a patient and then a bite guard would be at the mouth, by not unlocking this and pulling the transducer out, it will actually hit the back of the molars of the patient and scrape that lens pretty good. So as they're dragging it out, because there's pressure to keep this at 90 degrees, it will drag against the back of the molars. And so what we recommend, talking with the technicians out there, all you gotta do is unlock it and let the probe relax straight. And as you pull it out, it prevents the molars from hitting the most sensitive part of the probe, which is that crystal. Another item to talk about is where the handle is actually stored during a procedure. We recommend that it's stored hooked next to a patient, but we often see that this probe is resting somewhere, and once the procedure's over, this handle is very heavy. This is the heaviest part of the transducer. It will slide off of a surface and then drag this probe down, and the probe will smack and hit that. So if you heard that smack, that probe is now broken. All right, we wanted to show during clinical use of some more standard probes that are more in a traditional ultrasound scanning room. We have our probe here for those that are scrutinizing the equipment. Yes, we know this probe does not work with this machine. This is purely for just demonstrating the vulnerability during normal use of a transducer. And so oftentimes a sonographer will be working on a probe and hey, accidents happen. And so what happens is they'll be scanning, and then all of a sudden the probe may slip out of their hand and it will actually drop to the floor. That drop, this will naturally drop on its face, the most sensitive part of the crystal. At that point, you've cracked the crystal, and it can be repaired, most likely replaced at that point, because when that impact happens on these hard surfaces in these hospitals, that impact is so significant. It may not seem that significant to us, but this falling straight onto a hard surface from about a few feet up will destroy a probe. Another vulnerability is the probe might not hit the floor and something will slip out of their hand. And if it slips out of their hand, they'll grab this cable. to try and catch it. So when you grab it and you hit it, it becomes a lasso. As you see, it starts swinging down. And now I'm actually going to drop it enough to swing down, and it'll hit that. And it hits the side right here, because obviously it's going to be a pendulum. You catch it here, the force comes down, and when the force comes down and hits the surface, you knock the side of all the microcircuits around the crystal, causing a massive amount of damage. So keep hold of this, protect this, and if it starts slipping, prevent that from actually grabbing the thing. Grab this head of the probe so it doesn't swing down and really impact something that will cause damage to the internal electronics. Yep. And so in the OR, in clinical use, there's a variety of other factors. Those are the main ones that we see that are really common, and some really small adjustments on how it's being handled will prevent a lot of failures to continue this life cycle for your transducers and continuing to help you serving patients. And so, many healthcare facilities use totes to transport transducers around. And I think that's a phenomenal idea, but we got to make sure that we take care of the crystal in keeping it away from the connector of a transducer. This is heavy, it's full metal. This is sensitive with a small rubber layer that protects the most sensitive and most important part of the transducer. And as we're walking down the hall and things move a little bit, boom. The connector hits that crystal, and at that point, that impact is enough to disrupt the microelectronics inside of this transducer to cause imaging issues. It could cause color noise, it could cause CW noise, it could cause dropouts in your image. It could even cause the probe to malfunction and not even turn on anymore. And now we have a similar tote for a T-probe. And as you can see, same rules apply, but you got another variable is this really heavy handle. And as you're walking around, in this particular case, this will be banging against the handle, the metal piece. It'll hit as you're walking around and shimmying this around on accident just by natural walking motion. So we really recommend that we just keep the tip away from the metal parts and preventing impact. All right, now we're going to go on to the next phase of the life cycle of a transducer, and that is going to be decontamination. So we're out of the surgery, we're out of the clinical use, went to transport to central processing, and now it's time to get all those fluids and debris off of the equipment after its use on the patient and helping them out. And so the idea during decontamination is to protect the electronics of the equipment. And so specifically for T-probes, there's two areas that we've seen where you do not want any fluids, water of any type to enter. And the handle and the connector have very sensitive electronics that don't have the types of protections that the electronics in the tip of the T-probe do. And so what happens is these may be washed during the decontamination process. Now we have fluid ingress into electronics that the first time you power that up on the next study can cause some extreme shorts and actually cause massive failures in the equipment itself. So imagine your home computer, you're dumping a cup of water inside your home computer. You don't have a good shot when you turn that thing on and there's still fluid in there for those electronics to not short themselves out and at a degree of failure where it just won't run anymore. We see a lot of fluid ingress in the handle, in the connector of T-probe transducers, and that's something that we want to share because we know that with how many patients healthcare facilities are trying to assist right now, it's these small details and trainings in these decontamination departments that will actually prevent a massive number of failures and keep your equipment up and going so you can keep serving patients. So now we want to talk about decontamination as you're rinsing off this probe, getting all the debris and the fluids after a scan. And now it's here to be rinsed off essentially. And we have it on a table here, but here's one thing that we've seen a lot. Things are wet, things are slippery, and what happens is this will move around, and as you move the handle around, you can see how much it moves the rest of the insertion tube around. Well, because things are slippery, wearing gloves, the probe will slip and bang the side of the cabinet. That's enough to obviously disrupt the electronics on the tip. So we highly recommend this is stable. We've seen contraptions at healthcare facilities instituted after we've been there to hold this handle here and then controlling where the tip's going to eventually be. And so now, as we use some fluids to start decontaminating this probe, do not decontaminate the handle. We've seen all too often where technicians will actually start putting fluid all the way up the probe, thinking that we're doing a phenomenal job of actually decontaminating the probe. Well, if we look inside here, there's already corrosion in this probe, and you can see now there's a bunch of gearing and also electronics on the inside here where you can already see some corrosion. And those electronics, when fluid gets in, will cause shorting and cause your transducer to fail. So again, we want to keep fluid outside of this handle, as this probe was never intended to have anything behind the insertion tube be immersed in fluid. We've even seen so much so where technicians will actually wash the connector where all the high voltage electronics are stored, causing massive shorting inside this connector, and therefore shorting here. The circuits run all the way up the probe and can short your crystal at the same time. So a lot of slippery surfaces here. Do not drench the fluid behind the insertion tube. You can wipe this down, but don't soak it. We've also seen the handle and the connector being soaked in the baths that actually decontaminate the probes post this rinsing process. Or it slides into the decontamination receptacle. Don't want these. Keep these dry as much as you can. Do not immerse these in any fluids, or you will get a lot of failures and take the equipment out of commission. The next phase of the life cycle we're going to chat about is inspection and testing. So in working with a lot of hospitals and healthcare facilities over the years, we actually found that after decontamination, we should be inspecting this equipment to see if there's any failures, because at this point, if you can catch the failure here, the chance of repairability and the speed of the repair will be much higher than if it wasn't caught here and the probe went through several more life cycles with this damage. And the kind of damage that we see most often is micro abrasions and punctures on T-probes at this soft bending rubber. Now, we talked about this before. Well, now let's talk about the consequences of that on not catching it early. And so what happens is that if you don't catch these very small punctures, if you actually fast forward to the next phases of the life cycle, disinfection fluid may get inside these micro punctures if you don't look for them. And then it gets stored for a while, and that caustic chemical will sit on the metals of the internals of the electronics of the tip. And then it will actually degrade and corrode over time. And then what happens is, this happens a few times, the corrosion continues to escalate. And the problem with corrosion is that it eats the materials away to where there's literally no materials left. Now the idea here is if we can catch these failures early, it could be as simple as just replacing the bending rubber and you're off to the races and you can actually begin scanning again, which is a fraction of the cost of waiting several life cycles, and there's so much corrosion where the probe may not be repairable anymore and it forces a replacement. Well, the replacement of this equipment can be very costly, but a simple repair of cleaning out the inside of the tip and then replacing the bending rubber with materials that don't have a puncture in it anymore and sealing the probe back up is a fraction of the cost. So what do you do during inspection and testing? Well, we go to a lot of facilities and we recommend getting a high-powered magnifying glass and a nice light and training those techs that are decontaminating your equipment to look for micropunctures, abrasions, cuts, fractures, gouges on the tip, and if there's any thought that there could be damage, get it in for repair as quickly as you can. The faster you can get it into repair, it prevents the corrosion from occurring. And so the important part here is that because this is a bending rubber, if there is a puncture and it's straight and it's relaxed, the rubber naturally comes back together. And if it gets into disinfection and then during disinfection you do a leakage test, that puncture is now relaxed and pushed back together. But when it's articulated like this, it now exposes that puncture a little bit, and then that would happen during a scan or some other part of the process where the rubber, by virtue of the material, when it's relaxed, it can actually cover things up and actually pass a leakage, but the moment you bend it, it will actually open that up and it would fail leakage at that point. So we recommend using the equipment that we talked about, the magnifying glass, the light, a nice set of eyes, and actually bending it around and seeing if it exposes any punctures or lacerations. If you see anything, get it in for repair as quickly as possible. That's a quick, inexpensive repair relative to the price of the probe, and you are back in business and actually enabling and extending the life of the equipment and avoiding that costly replacement. Now, when we're inspecting a traditional transducer, we really want to look at the lens and seeing if there's any lens damage. Everything from gapping and peeling of the edges to small lacerations and cuts on the surface of the lens. We're seeing a couple things. Surgical brushes do not belong on the face of these probes. They should not be used on the tips of these probes. These surgical brushes are really abrasive, and this equipment just isn't built to take that kind of abuse. Another one is as you're wiping these probes down, be gentle as you're wiping it. We've seen some where some technicians are wiping it so hard where it starts pushing the lens away from the edge, and now you got a gap. And then once that gap is there, you throw on some ultrasound gel, and that fluid then penetrates into there, corrosion begins, and that's when the failures really start to occur. And then the electrical properties of the probes are now vulnerable to the patient. And so that's something to look for on these probes as well. And something as simple as a very small cut in the lens could be easily repaired and very quickly repaired. And if it is not resolved immediately, the vulnerability is that now you got fluid intrusion from the ultrasound gel of your transducer getting into the electronics underneath that lens and then causing corrosion. And if the corrosion sits there for too long, you're going to suffer image quality issues, and then at a point there's no materials left to repair, and therefore forcing a costly replacement. Now we're going to talk about disinfection. There's a lot of machines out there. TD100 is great. There's a lot of other methods on doing it. Reference your service manual. But during the disinfection process, we want to highlight this inspection and testing phase, because if there is any punctures, you don't want the disinfecting fluid to actually go through these small micro punctures into the internals of your transducer. And so this disinfection process now becomes much safer once it's confirmed that visually everything is good to go. You can do your leakage test here as well. And then now this is a safe process because those chemicals are pretty acidic. They corrode very quickly inside these transducers, causing a ton of damage on the internals. So disinfection is, in our opinion, as long as you hit inspection and testing thoroughly, becomes a really safe proposition on not damaging your equipment during the life cycle. And so on to transportation storage. We chatted about that before. Same types of rules apply as transport, to the operating room. And then T-probe storage. Storage of these probes and probes in general. Again, same thing as transport. Keep the probe head away from the connector and don't accidentally, kind of bang on here on these really hard surfaces. That will rattle the electronics really well, and you'll start seeing some failures in image quality first, and then ultimately the probe just won't run anymore. T-probes, we highly recommend. They are hung in a storage cabinet like this. And so now as we talk about storage of T-probes, keeping the connector away from the tip, protecting the tip to where it's not going to bang on anything down here. But what's really important here, and I wanted to demonstrate, is that if we skipped inspection and testing, there could be some fluid from a micropuncture in the tip of the probe. Well, it's recommended it's stored vertically like this to prevent this from assuming a permanent position of being coiled. We want this to be straight so it can go and scan a patient as easily as possible. But guess where all that fluid's going? It's actually running down the tube. If it's penetrated from the handle, if it's penetrated from the bending rubber, then it's just all really going to cascade down into the crystal. And guess what? The highest concentration of fluid is going to be moving to the most sensitive part of this transducer. So double-clicking on the inspection part of this life cycle is where we think the most value could be generated inside the life cycle of a probe, because this will allow you to catch failures early, take advantage of that repair process, which is a fraction of the cost of a replacement, and lower your total cost of ownership on your equipment. So again, inspection and testing, highly recommended and oftentimes missing in the process of the life cycle of maintenance and service of these transducers in a hospital. So that kind of does it for the day. If you have any questions, our technical support team is available to help with all of these sorts of questions 24 hours a day. And if you need any help with any repairs, we're always at the ready to help healthcare facilities repair their assets, lower the total cost of ownership, and continue serving patients, because ultimately, when we look at the life cycle of a transducer, the more we can prevent damage and the earlier we can catch damage, you can really elongate the life of your equipment. And in doing that, it allows you to continue to be available to patients and not suffer downtime and run and operate at a capacity that you want to keep our population healthy. And so thank you so much. We hope you enjoyed the content today. You guys have been talking to us constantly and saying, hey, we need a real demonstration of how are these things failing? What are the biggest points here? What can we do? And this is just a collection of information from all of our customers working with us. We just want to share it with the general public here. So thank you so much for joining us. Larry Wynn again here at Summit Imaging. And Thank you so much to all the frontline workers out there, and let us know if there's anything else we can do to help you. Hope you enjoy. Thanks.